We stand at the cusp of a revolution in healthcare, a revolution fueled by the convergence of genomics, biotech, and digital health. Imagine a world where diseases are predicted before they manifest, where treatments are tailored to our unique genetic makeup, and where healthcare is accessible at our fingertips. This isn't science fiction, this is the future that these technologies are shaping. This transformation is deeply personal. It's about understanding our own individual blueprint of life encoded within our DNA. It's about harnessing the power of biology to treat diseases at their root, correcting genetic errors and engineering new therapies. And it's about using technology to empower ourselves with knowledge, to monitor our health proactively, and to access healthcare seamlessly. This essay will delve into the exciting possibilities of this new era of medicine. We will explore how genomics is unraveling the secrets of our DNA, how biotech is pushing the boundaries of what's possible in healthcare, and how digital health is changing the way we experience healthcare. We will also navigate the ethical considerations that accompany these powerful technologies, ensuring their responsible and equitable deployment for the benefit of all humankind. Join me as we embark on a journey into the future of medicine, a future that is personalized, precise, and incredibly promising. At the heart of this revolution lies genomics, the study of our genome, the complete set of genetic instructions that make us who we are. Our genome, a complex tapestry of DNA, holds the code for our physical traits, our susceptibility to diseases, and even our response to medications. Genomics is like reading the book of life. By decoding our DNA sequence, scientists can identify variations that might increase our risk for diseases like cancer, diabetes, or heart disease. This allows for early detection and personalized preventive measures, such as lifestyle changes or regular screenings. Moreover, genomics is paving the way for personalized medicine. Our genes influence how our bodies respond to drugs, and genomic testing can identify individuals who are likely to benefit from a particular drug or experience adverse reactions. This targeted approach increases treatment efficacy and minimizes side effects. Genomics is not just about predicting and treating diseases, it's about understanding life itself. It's about unraveling the mysteries of our biology, tracing our ancestry, and exploring the vast diversity of life on Earth. If genomics is about reading the book of life, then biotech is about editing it. Biotech encompasses a vast array of technologies that harness the power of biology to develop innovative solutions in healthcare, agriculture, and beyond. In the realm of medicine, biotech is leading the charge in developing targeted therapies, engineering new drugs, and even curing previously untreatable diseases. One of the most exciting areas of biotech is gene editing. Using tools like CRISPR-Cas9, scientists can now precisely target and modify genes, offering the potential to cure genetic diseases at their source. This revolutionary technology holds immense promise for treating conditions like cystic fibrosis, sickle cell anemia, and Huntington's disease, offering hope where there was once despair. Beyond gene editing, biotech is driving advancements in personalized medicine, developing therapies tailored to an individual's genetic makeup and specific disease characteristics. From cancer immunotherapy to stem cell therapy, biotech is revolutionizing how we approach healthcare, moving away from a one-size-fits-all model towards a more precise and effective approach. Gene editing, a revolutionary technology in biotech, is akin to having a molecular scalpel that can precisely target and modify our DNA. This groundbreaking tool empowers scientists to correct genetic errors that underlie various diseases, offering a potential cure for conditions that were once considered untreatable. Imagine a world without genetic disorders like cystic fibrosis, a debilitating lung disease, or sickle cell anemia, a blood disorder that causes excruciating pain and organ damage. Gene editing holds the potential to make these aspirations a reality. By correcting the faulty genes responsible for these conditions, we can alleviate the suffering of millions worldwide. The impact of gene editing extends beyond treating inherited diseases. It's being explored as a potential weapon against cancer, allowing us to engineer immune cells that can target and destroy cancerous cells with laser-like precision. Researchers are also investigating its use in preventing infectious diseases like HIV by modifying immune cells to resist viral infection. While gene editing is still in its nascent stages, the rapid pace of advancements in this field is astonishing. Startups and research institutions worldwide are making remarkable strides in translating this technology from the lab to the clinic, offering hope for a future where genetic diseases no longer dictate our destiny. Section 5. The rise of digital healthcare. While genomics and biotech are transforming healthcare from within, digital health is revolutionizing how we access, experience, and manage our health. From artificial intelligence or AI, powered diagnostics to wearable health trackers, digital health is empowering individuals and transforming the healthcare landscape. Imagine a world where you can get an AI-powered diagnosis from the comfort of your home, where your smartwatch alerts you to potential health issues before they escalate, and where you can consult with a doctor remotely via telemedicine. This is the promise of digital health, making healthcare more accessible, convenient, and patient-centric. AI in particular is playing a transformative role in healthcare. AI algorithms can analyze medical images like X-rays and MRIs with remarkable accuracy, aiding doctors in early and accurate diagnosis. AI-powered chatbots are being used to provide personalized health information and support to patients, while AI-driven drug discovery platforms are accelerating the development of new treatments. Digital health is not just about technology, it's about empowering individuals to take control of their health. With wearable health trackers, people can monitor their fitness levels, sleep patterns, and even heart rate variability, gaining valuable insights into their overall well-being. Health apps provide personalized guidance on nutrition, exercise, and stress management, promoting preventive healthcare practices. Section 6. India's digital health revolution. India, with its vast population and diverse healthcare needs, is witnessing a digital health revolution. The convergence of technology and healthcare is bridging the gap between urban and rural areas, making quality healthcare more accessible and affordable for millions. The Indian government's flagship initiative, Ayushman Bharat Digital Mission, is creating a unified digital health ecosystem. This ambitious project aims to provide every citizen with a digital health ID, linking their health records electronically and enabling seamless access to healthcare services. Telemedicine, in particular, is transforming healthcare delivery in India. With a shortage of doctors, especially in rural areas, telemedicine platforms are connecting patients in remote villages with specialists in urban centers, enabling timely consultations and treatment. This is particularly crucial for managing chronic conditions and providing specialized care. India is also witnessing a surge in health tech startups developing innovative solutions for various healthcare challenges. From AI-powered diagnostic tools to mobile health apps for maternal and child health, these startups are leveraging technology to address India's unique healthcare needs. Section 7. The ethical frontier, navigating the challenges. While the advancements in genomics, biotech, and digital health are awe-inspiring, it's crucial to acknowledge and address the ethical implications that accompany these powerful technologies. As we venture into uncharted territory, we must proceed with caution, ensuring that these innovations are used responsibly and equitably for the benefit of all humankind. One of the most pressing concerns is the privacy and security of genetic data. Our genome is the ultimate blueprint of our identity, and safeguarding this sensitive information is paramount. Robust data protection measures, informed consent protocols, and stringent regulations are essential to prevent misuse or discrimination based on genetic information. Another ethical consideration is the potential for AI bias in healthcare. AI algorithms are trained on massive datasets, and if these datasets reflect existing biases in healthcare, the resulting algorithms may perpetuate or even exacerbate these inequalities. Ensuring diversity in training data and rigorous testing for bias are crucial steps in developing fair and equitable AI-powered healthcare solutions. Section 8. Genomics and Biotech in India, a budding landscape. India, with its rich scientific talent pool and burgeoning biotech industry, is well positioned to become a global leader in genomics and biotech. The country is witnessing a surge in genomics research, with initiatives like the Genome India project aiming to create a comprehensive genomic database of the Indian population. This database will be a valuable resource for understanding disease prevalence, drug response, and population-specific genetic variations in India. It will pave the way for developing personalized medicine strategies tailored to the Indian population, improving healthcare outcomes for millions. India is also home to a growing number of biotech startups, developing innovative solutions in gene editing, drug discovery, and personalized medicine. These startups are attracting significant investment, both domestic and international, indicating the immense potential of India's biotech sector. However, to fully realize the potential of genomics and biotech in India, several challenges need to be addressed. These include bridging the gap between research and clinical application, fostering collaborations between academia, industry, and government, and ensuring equitable access to these transformative technologies. Section 9. The future of medicine: predictive, preventive, and personal. As we stand at the intersection of genomics, biotech, and digital health, the future of medicine looks incredibly promising. These technologies are converging to create a healthcare system that is more predictive, preventive, and personalized than ever before. Imagine a world where diseases are detected before symptoms even arise, where treatments are tailored to our unique genetic makeup, and where healthcare is seamlessly integrated into our daily lives. This is not a distant dream. This is the future that is within our reach. Genomics will empower us to understand our predisposition to diseases, allowing for early interventions and personalized preventive measures. Biotech will provide us with an arsenal of targeted therapies, curing diseases at their source and extending our lifespans. Digital health will connect us with healthcare providers seamlessly, empowering us with knowledge and enabling us to manage our health proactively. The future of medicine is not just about living longer, it's about living healthier, more fulfilling lives. It's about empowering individuals to take control of their health, making informed decisions, and accessing quality healthcare when and where they need it. As we continue to unravel the complexities of our biology and harness the power of technology, the possibilities for improving human health are limitless.